Hey everyone, today I wanted to share a quick tip on how to scan client-side JavaScript files with free static code analysis tools to find client-side injection vulnerabilities for bug bounty hunting. Now while you're out there, you're definitely going to find applications that use React for their front end. React is a free, open source, and very popular front-end JavaScript library that's maintained by Meta along with a fantastic community of developers. React works by creating an in-memory virtual DOM rather than actually manipulating the browser's DOM. This sounds really complicated, but all you really need to know is that the React code is compiled into minimized JavaScript files that are loaded onto your browser. Now, you've probably seen these chunk files while testing. Large JavaScript files that are returned immediately when the page loads, right? When a developer compiles those React files, they typically run that code through an obfuscator tool. If this step isn't taken, you as a security researcher can get access to the original React code through the developer tools. To do this, first check Wapalizer, or whatever you want to use, to identify an application that's using React. Next, you need to open the dev tools and navigate to whatever tab loads the client-side JavaScript files. And that's going to be sources in Chrome, debugger in Firefox. We need to look at these JavaScript files to determine whether the React code was actually serialized properly. Now, every application is going to be different, but in most cases, you want to look at a folder labeled SRC, short for source. You can also look for instances where the React framework is being imported in these files. If you see that, you know you found a React front-end file that's not serialized. And once you've identified a target application that doesn't have the obfuscated React code, the next step is actually download that using the JS Miner extension in Burp Suite. You need to install the extension first, so you can open up Burp Suite and navigate to the extensions, App Store, and then just scroll down to where you see the JS Miner Pro extension. You can scroll to the bottom of the frame on the right, click that orange install button, you'll install the extension there. Once you're done, you can download the source code of the target application by navigating to the sitemap under the Target tab. Right-click on the root of the target app, then hover over JS Miner, scans, and then finally click on the JS Source Mapper Active Scan option. Once the Source Mapper scan is complete, you'll see the information issue under the Issues tab on the right. Clicking that finding is going to show the directory where you can find the raw React code used to compile the front end of your target application. Now, all we need to do here is scan these React files from any static code analysis tool. For this demo, I'm going to use SimGrip. SimGrip is a phenomenal tool that not only scans for known code patterns associated with vulnerabilities, but you can also build your own checks with a simple YAML file. That's why I love it. These custom templates are where clever bug bounty researchers make their real money using this technique. For now, though, let's just focus on installing and running the tool. It's going to be something for a different video. You can install SimGrip using pip. Super easy. Just type Python 3 tac m pip install SimGrip. Once the tool is installed, it should be added to your path, and you can confirm that by just doing SimGrep tac version. If your output looks different than mine, you need to go back and troubleshoot or potentially try a different tool, but I'm just going to keep moving for the sake of this one. Once you've got SimGrep working, simply navigate down to the folder with the newly downloaded React files, and you can run SimGrep scan. Within a few minutes, it's going to do everything for you, but you'll have detailed output about what code patterns were identified as a potential vulnerability. Now, I don't want to get too deep into validating these rules. That's another topic for another day, but I do want to highlight one finding that I always keep an eye on, right? React uses JSX under the hood, which makes traditional client-side injections like cross-site scripting very, very difficult. But there's an exception. If the developers wish to render output into the DOM and have that output actually be processed as HTML, they can use the dangerously set inner HTML method. That method specifically bypasses JSX, and this is most commonly used when developers want to render HTML. Maybe they're doing an email template, something like that, right? A check for this method is built into the basic SimGrep scan, so if you find that method being used, it is time for you to start looking for a cross-site scripting. Okay? Anyway, I hope that's helpful. If you want to submit reports directly to my team, you can find our public bug bounty program on HackerOne by searching for Flowcast. That's FLOQAST, or go to hackerone.com/Flowcast. And finally, if you want to hire me directly for any private tutoring or penetration testing, you can find me on Fiverr Pro under my company name, Arson Security. Cheers.